Most of the world's volcanoes are in subduction zones, but there are exceptions. Kilauea is on the big island of Hawaii, part of a chain of islands in the middle of the Pacific Ocean, thousands of miles away from any subduction zone. But the whole chain is formed entirely from volcanoes, whose rivers of fire heave and bubble at temperatures of 2,000 degrees. What provides the furnace for all this outpouring if it's not the crashing of the tectonic plates? The volcanologists have an explanation.
The lava that's flowing and spattering behind me is the surface manifestation of a thermal anomaly, or a hot spot that's deep within the earth beneath my feet. Where we are now on Kilauea Volcano on the big island of Hawaii is at the southeast end of a 6,000 kilometer long chain of seamounts and volcanic islands that have formed as the Pacific Plate has moved north and westward over the last 80 billion years or so at a rate of around 9 or 10 centimeters per year. So as the plate moves over this hot spot, you burn through the lithosphere, forming a volcanic island, and then the plate moves on, and a new island forms further to the southeast.
The hotspot has made Kilauea the tallest mountain in the world, 30,000 feet from its base on the seafloor, taller even than Everest. It's also one of the most studied. But scientists can't always wait for the lava to come to them. They must catch it as it bursts through the crust. Carl Thornber often goes fishing with a cable in a red-hot pond. And sometimes he has to get even closer. It's extremely dangerous. At any moment, the lava may spurt out unexpectedly, leaving Thornber with nowhere to run.
Behind me is a perched lava pond that's being fed from a vent off to my left. You can see that there's lava spattering and overflowing on its edges. I'm going to attempt to scoop a sample of molten lava, hopefully with a hammer, so I won't have to use a long cable to throw it in. And it'll be extremely hot. We have to worry about gases, and we have to worry about breakouts near the edge of the pond. So we'll see how it goes.
Thornber is risking his life. But unless scientists can learn how to forecast eruptions, volcanoes will continue to be an uncontrollable threat.
Okay, we'll take this sample back to the USGS Observatory and we'll prepare it for chemical analysis. The chemistry of Hawaiian basalt is unique compared to volcanic deposits near subduction zones or near mid-ocean ridges, and that will be reflected in the chemistry that we see. More importantly, we're looking at very subtle variations in chemistry that can be correlated with the eruptive history of this volcano. So it will allow us to predict what may happen next